Welcome to my YouTube channel. In today's video lesson, we are going to be doing Waec Chemistry Practical 2024. In this video lesson, I'm going to show you how you can get the end point of your titration experiment without using any apparatus. Yes, you can do that. You can get your answers to the burette reading without using any physical apparatus. All you need to do is to get the specimen that is to be provided by your school. And from the specimen that is provided for 2024 Waec exam, the specimen stated that each candidate should be supplied with the following, where N is the word candidate serial number. Now, what does this specimen contain? This specimen contains, number one, they were told to give the students 150 cm of potassium tetraoxomanganate 7, which is your word KMNO4. Of course, this guy must be acidified. To acidify means that you are going to add few drops or 20 cm of H2SO4. The purpose of acidifying this guy is to remove any interfering gases that might be absorbed by the KMNO4 during the experiment, so as to prevent you from having a wrong reading value. So KMNO4 is always acidified with H2SO4 so as to precipitate interfering gases. Now, A is 150 cm of potassium tetraoxomanganate 7, KMNO4, in a cork flask labeled as AN. Okay, this AN is your acid, but in this particular experiment, we don't have acid and we don't have base, because in 2024 practical analysis, we found out that it is basically what? Redox titration. This one differs from the normal titration you used to know. This one is redox titration. In redox titration, we titrate an oxidizing agent with a reducing agent, of which your KMNO4 happens to be the word oxidizing agent. So it's standing at the acid in your normal titration. So the teacher is to provide 150 cm in a cork flask containing KMNO4. Okay? Now, how should this KMNO4 be prepared? Go on. They said this should all be what? The same, containing 1.58 gram per dm³ of KMNO4 solution. That is to say, the solution should be 1.58 gram. This is the mass that should be contained in 1000 cm³ of this guy. So if you have this mass in this guy, this becomes the mass concentration. Don't forget, I want to show you the tricks on getting your endpoint without having to do any experiment. Number two, 150 the same for FeSO4. This guy is your reducing agent, which is functioning as the base. Okay? In a cork flask labeled as Bn, remember your N is your serial number. Then this should all be the same. This is now the mass concentration of the reducing agent. So we are titrating oxidizing agent against what? Reducing agent. Now, in this type of titration, we do not need any indicator. Why? Because this guy is already colored. It has a purple color. So it's not like in acid and base where both of them is colorless. If one of them is colorless, to identify the endpoint, there should be a color change. So that is why we have to put indicator in ordinary titration. But in redox, we do not need an indicator because one of the reagents already have color. So by the time the color changes or decolorizes, we'll know that that particular point is called the endpoint. So we are doing this without experiment. So what we need to do is to take note of this. So get your book and your pen and write this down. This is called the mass concentration of A. This is the mass concentration of B. This is your oxidizing agent. This is your reducing agent. Where do we begin from in determining this endpoint? In this video lesson, I'll show you how to get your endpoint and how to draw your table. Then in our next video lesson, I'm going to give you predictions of questions that you are likely to see in your exam. So now we begin by balancing the equation, not the ionic equation. In doing the calculation, you might need the ionic equation. But to determine the endpoint, you need the normal equation. This is the equation between the oxidizing agent called A and the reducing agent called what? B. Okay? And these are the what? The end product. We are balancing this under an acidic medium. That's H2SO4. So write it down. This is your A, while this is your word? B. How many moles do we have for A class? 2 moles. How many moles do we have for B class? 10 moles. So note this, please. This is your A and this is your word, your B. So please forgive me to do this. This is our base, though we know that it's reducing agent. This is our word RC. So take note of this. This is your RC, this is your base, although this is reducing agent, oxidizing agent. Remember, your base is always in your pipette. And in your pipette, remember that the volume of the pipette that is recommended is 25 cm3. So that means we already know the volume of the base. Let's do that. Volume of the acid, we do not know. But do we know the volume of the base? Yes. Volume of the base is equals to 25.0 cm3. It will be important, so write it down. So the purpose of any titration is to know the volume of the acid. It's not volume of base. You put the acid into the burette and you already know the volume of the base by using your pipette to sieve 25 cm3 and put it to a conical flask to titrate. Are we together? Now watch this. Watch this. So this is your acid, volume of acid, this is your volume of base. We don't know this, but we know this. Now, what can we get from the specimen that was given to us? What can we get? Very important. Now this is what I'm going to do. I want to get the molar mass of your KMNO4. I will get the molar mass of your FeSO4. We don't need the number of moles now because we are not using the titration formula. So let's get the molar mass of KMNO4. Molar mass of KMNO4. KMNO4. Let's get the molar mass. Let's quickly do that. Remember, the molar mass of potassium is 39 plus manganese. Let's do that. 55 or 54.9. So we can use 55 plus 16 times 4. Okay? So let's get the molar mass. Let's use our calculator to get it. Okay, let's do this quickly. 39 plus 55 plus 64. 158. So if you do this, you have 158 grams per mole. This is the molar mass of A. Now let's get the molar mass of this one, SO4. So let's do this. Molar mass of what now? FeSO4. Let's do that. Remember the mass of iron is what? 56. Sulfur 32. Oxygen 16 times 4. So what do we have? We have 56 plus 32 plus 64. Let's do that quickly. $56 plus 32 plus 64. We have 152. So we have 152 grams per mole. If you have known the molar mass of this and the molar mass of this, then you're already halfway to your success. Why did I say so? Remember that number of moles is mass over molar mass. Do you remember that concentration in mole per dm³ is equals to mass concentration in gram per dm³ over the molar mass? So with this one, we can know the concentration of A and the concentration of B. Why did I say so? If I need Ca, what will I do? Very easy. It is the mass concentration of A. What is the mass concentration of A? 1.58. So we have 1.58 over the molar mass. What's the molar mass of A? We have solved it. So you have 158. What will this give us? 1.58. Okay, I think we have 0.01, right? Good, thank you. Mole per dm cube. Now, how do we get Cb? Our Cb is the same thing. Mass of the concentration of the base, which is 5.5 over molar mass. What molar mass? You have 152. So what would that give us? Cb will give us what? Please do that for me. 0.0. Good. So you have 0.036 mole per dm cube. Wow. Class, this is the concentration of A. So please take note of this. In the course of your calculation on the day of your exam, when you are told to find concentration of the acid of A, this is what you are supposed to get. To find concentration of B, this is what you are supposed to get. Okay? So this is the concentration of the acid on the experiment that you are yet to conduct. Why this is for the base. So take note of this. Though there may be slight variations, but it shouldn't be too far from these values. Okay? Now, that is why this particular video lesson is not just for students, but it's for student and teacher. So you have to prepare your solution very well so that your contribution should not vary. The difference should not be too much. Okay? Now let's quickly do this. What will now be the volume of the what? A that we are looking for? Very easy. Remember the general formula for titration. You have CAVA all over what? CBVB equals to what? NA over what? NB. Are we together? So I have known this. Although on the day of your exam, you are going to be told to calculate this. So write it down. You're going to be told to calculate this. Okay? Now, how do I know the VA, the volume of the acid? Because I told you the most of the experiment is to know VA. So how do I do it? What is CA? Do I know CA? Yes. See, I'm here. You have 0.01 times VA. Do I know CB? Yes. See, I'm here. 0.036 times VB. Remember I told you that VB is the volume of the base. See, I'm here. 25. So you have 25 equals to NA. What is the number of moles of A? See, I'm here. 2. What number of B? See, I'm here. 10. So you have 2 over 10. Wow. That's interesting. Let's please get this. Remember we have to cross multiply. If I cross multiply, I will have 0.01 VA times this 10 equals to 0.036 times 25 times 2. If I multiply these 2, I will have 0.1 VA, isn't it? Equals to, please multiply the 0.036 times 25 times 2. 1.8. Good. Just 1.8. Just 1.8. So we have 1.8. Divide both sides by what? 0.1, 0.1. So this, demystify this. VA is equals to 18.0 cm cube. So in your experiment, you have to get 18.0, or your value should not be too far from what? From 18.0. You are likely to get 18.1, 18.2. Now, I am going to show you how your table is going to look like. Now, we are going to check how to draw the titration table. Remember that I just showed you how to get your endpoints, of which your teacher is going to give you. Your endpoints, the one we have calculated for that is 100% accurate, is what? 18.0 cm cube. So how do I draw my titration table? Given that this is my endpoint, very easy. All you have to do is this. Number one, you first of all write your pipette reading. Your pipette reading is the same as what? Volume of B. Remember, your pipette has a standard volume, and what's the value? It is 25.0 cm3. This 25 is what influences us to get this. Take note of that. Then that's what we do on the table. What is your indicator? Remember, this is a redox titration. In a redox titration, there is no indicator. So write no indicator. Then what do? We do this. Remember that your base is always in your pipette, which is B, while A is always in your burette. So we can do this. Burette readings. These your burette readings are: number 1, final burette readings. Number 2, initial burette readings. Number 3, volume of A used. Remember, A is the acid, also called the oxidizing agent. Okay? Now this should be in CMQ. Take note. So all of these are in CMQ. Then what you have here, the first column should be for your rough titer. Rough titer. Your rough titer should be in CMQ. Take note of that. Your next one should be what? First titer. It should also be in CMQ. The third one, you have second titer. Your second titer should also be in CMQ. Then finally, you have third titer. This is for accurate determination of the word volume of A. Remember, I've already given you that your endpoint is 18.0. If your endpoint is 18.0, you can get the others very easy. Make sure your rough, you can put any value for your rough. So let's take a value bigger than this and put something like 19.30. So if 19.30 is our rough, let's first of all your initial. Put 0 in your initial to avoid mistake. To avoid mistake, please put 0. Don't put 0 so that you don't have issues with subtraction. If you have done this, what do you have to do? Very easy. First titer, do this. Use your first value, 18.00. Second titer, remember that the difference should be plus or minus 0.2. So you can put 18.20, 18.10. You can do that. So there's either an addition of 2 or ruler of 2. So just put 20, or you can even put 10 and put 20. Please avoid values like 18.01. Why? Because the calibration of your burette is not to 2 decimals, it's to 1 decimal. So we can have 18.10, 18.20, 18.30, but don't go beyond 18.1 and 18.2. So that's why I have it this way. Now let's do our subtraction. 19.30 minus this will give you 19.30. This will give us 18.00. This will give us 18.10. This will give us 18.20. So this is very easy. I always tell my students that practical chemistry you can get your full marks. So class, if this is already what we have, this is already what we have. So what do we do? Very easy. The next is to calculate for average volume of A used. Remember, volume of A used is CMQ, and this is the rough, this is first, this is second, this is third. Please, because the rough differs entirely from this, so you can root it out. Don't use the rough. Just use this one. You have 18.00 plus 18.10 plus 18.20. Now, since you are choosing 3 values divided by 3, so you can get your average value. Let's quickly do this. 18.00, 18.10, 18.20. 54.30, 54.30. Divide it for me by 3, please. Do that fast. 18.10. Good. 18.10. Wow. This endpoint is what? Is sharp. It is what now? Sharp. So ladies and gentlemen and ladies, Aboki and Abokres, this is the endpoint for your titration experiment. Okay? If today is your first time for coming across the H2O channel, please do well to subscribe to this channel. Also, please. Now, I am going to be giving you predictions on the questions that is going to come out in titration in your Waec 2024 chemistry, also for physics, okay? More also, remember your experiment, your practical is two. One is redox titration, which is the one we just did the endpoint. But I'm going to be giving you questions and answers, likely questions that you are going to come across. Having known your endpoint, there are questions to solve using your endpoint, okay? So I will do that in my next video lesson. Also, we have the SWOT analysis. We also do our SWOT analysis. So stay on this channel. Share this to your friends preparing for Waec that are writing chemistry. Thank you very much. I will see you in my next video.